sqlite. Now here we're doing create table if not exists. So what this really is saying is I want this to be a restartable process and I don't want to lose the data. We're starting out, we do not have sqlite, any sqlite files, and so this is going to create the database and create these tables, but the second time we run it, we're not going to recreate the tables. We're going to be able to restart this because we're going to run out of rate limit before we finish this, but so we just have to wait however long the rate limit takes to reset, and we'll watch the rate limit go down. And so we're going to have a people table, and we're going to have a primary key and the name. The name is going to be unique, and whether or not we've retrieved it, and that's kind of from a previous one. But then there's the who follows who, the from ID to to ID, and so this is a direction, and we're going to put a uniqueness constraint in, just like we do in many-to-manys, that basically says the combination of from ID and to ID has got to be unique. We don't allow ourselves to put duplicates of the combination. So from ID can be 1 in many records and to ID can be 1 in many records, but 1 is only allowed once. And this is the crud we have to do to convince Python to accept the Twitter certificate. And so this is similar to some of the other stuff that we've done. We're going to enter a Twitter account or quit, and if we hit enter by itself, then we will actually go and retrieve a record that was not yet retrieved. And now we're actually pulling out two values, ID and name, and so we will grab fetch1 is going to give us a two-tuple basically, and we're going to store that in ID and account. Of course, that's like this is coming back with a two-tuple. First of which is the ID from the database. Limit 1 means we're only going to get one of these, or 0 of these. If there are 0 of these, that means there are no unretrieved Twitter accounts. Retrieved equals 0. Well, you'll see in a second that all the new accounts we put in are the ones for which we haven't retrieved. And again, given that our rate limit, we want to know which ones we've retrieved. Okay, and so what we're going to do next is we're going to check to see if the person that we just checked, which means the length of the account is greater, that we just were entered, we're going to check to see if they're already there. Okay, and we're going to select ID from people where name equals, so that's the one we just entered, and we're going to fetch one and grab the first thing because we only got one thing in the select statement here. And if this person that we just asked to see is not in the table, that means this is going to fail. We're going to do an insert or ignore. This or ignore is kind of redundant because we just checked to see if it was there, but we'll put that in just to be safe. And we're going to put the name in as the new account that we're looking at, and we're indicating that retrieved is 0, so that we will know that we haven't retrieved it yet. You'll see that we'll update that in a second. We commit it so that later selects will see this. So you gotta do the commit. This later select wouldn't see the one we just inserted, and we're going to ask how many rows were affected, and if it's not equal to 1, then we're going to complain about we inserted it, and we are going to do this thing. We're going to ask, hey, remember there was an ID up there, right here, ID integer primary key, and we did not insert this here, but we want to know what that ID is. And every time I was showing you that in lectures, I was saying it's really easy in Python to do this. And that's what we're saying is this cursor did the insert, but one of the things happens is after the insert, we're going to grab the last row ID, which is the primary key that was assigned by SQL. Okay? And so that means that one way or another, coming through this code here in line 45, one way or another, we're either going to know the ID of the user that was there before, or we just inserted one, and so we're going to know the primary key of the current user, and you'll see why we need that. So ID is the primary key of the current user that we entered right here. Okay? And now what we're going to do is do the Twitter URL augment with the OAuth and all the keys and the secrets and hidden.py. Instead, we're going to go through, let's count 1,000. Let's go count, what the heck, let's go 200, up to 200 friends. Save. No, let's do 100. We'll keep it that way. And then we're going to retrieve it, and we're retrieving the account. We're not going to print the nasty URL out. We could. Then we're going to open the URL with a connection, and then we're going to read that, and we're going to get the UTF-8 data from this, and then we're going to decode that and we're going to have the Unicode data. So the data string is a internal Python string with all that data representing all the wonderful characters. And of course, we're going to ask URL open to give us back the headers as a dictionary using this call, and we can see what how many we have left for the remaining, right? What's the remaining rate limit that we have, okay? And so then what we're going to do is parse the data with JSON load S. If, oh wait, I need a continue in here. Continue, okay, save. If we are going to parse this data, we'll print it out, right? So that means that this died, which means it's not syntactically correct JSON, basically. And who knows if we're ever going to see that, but at least when it blows up, it'll print this data out. We'll have to catch it, and then it'll continue. Actually, I'll make this a break, because if that's blowing up that bad, we should quit. Now, I don't yet know what happens when this rate limit says you can't have it. And so, but I do know that I expect when it's successful that there will be a key of users in this outer dictionary that we're going to get. And if this outer dictionary that if users is not in the parsed dictionary, then I'm going to dump out this data so that at least I can debug what happens when I've got some broken JSON. So the difference between this code is going to fail when the JSON is syntactically bad, meaning a curly brace isn't right or whatever. This code will trigger when I get good JSON, but I don't have a user's key in it, okay? So then, once we've retrieved it, we're pretty happy with it. We're going to update for our account that we're retrieving. We're going to set this as one of our retrieved accounts, okay? And then what we're going to do is write a loop that goes through all the friends of this particular user that we're asking and gets their screen name, prints it out, and then we're going to check to see if this one is already in our people database, because this is a spider. We're grabbing accounts, and so we'll do a friend ID and do a fetch one, grab the sub-zero thing, and if that works, if this person's not in there, this fetch one is going to blow up, which means we're going to drop down to the accept code. But if it does work, we have friend ID is the, that they're there and they're already in our database, right? They just weren't retrieved, okay? And so now if the friend ID wasn't there, we're going to do an insert into setting retrieve to 0, and then we're going to commit, right? Now, remember, row count is how many rows were affected by this last transaction, cur.row count, and we're going to die if that insert doesn't work. This is unlikely, unless somehow we've ran out of disk drive or something. And we're going to grab the friend ID as the key, the last row that was inserted. We're only going to insert one row, so it's basically the primary key of the row that we just inserted. So if you look at this code right here, it comes out the bottom one way or another with friend ID successful, right? Friend ID is either they're already in our database or they're not. And if we insert them, then we have it. And so now, this count new and count old is just so I can print out a nice printout. Now we are going to insert into the friend table, which is called the follows table in this case, from ID and to ID. Those are the two outward pointing foreign keys. And we have the ID of the account that we are retrieving the friends of, and then this particular friend. And so we're inserting the connection from this person to that person. And then we commit it. We want to commit these again so that later selects, when the loop goes back up, later selects get all of that data that's going on. Okay, so we do want to commit from time to time, and then we close the cursor at the very end. Okay, so let's run this and see what happens. Okay, so Python twfriends.py. Oh, of course, I am a refugee from Python 2, so I always forget to type Python 3. Okay, so we're going to start. If we take a look right now, I'm going to start another tab over here, and ls-l star sqlite. Now that SQLite file is there, right? And it's actually made the tables. If you go up here, it ran all this stuff. Create the tables, yada yada, and we're sitting right here at this line. As a matter of fact, I think without causing too much trouble, I can open